10. Identify and label the Bronsted-Lowry acid, its conjugate base, and then the Bronsted-Lowry base and its conjugate acid in each of the following equations. And then we have this lovely equation right here. So we have H2PO4 minus plus OH minus, which will yield HPO42 minus plus H2O. And with these four components, 1, 2, 3, 4, we have to find four different things. Okie dokie. So the easiest way to go about this is to first match up your pairs. So I like to work from left to right all the time. So I'm just going to pick this molecule right here, this ion. All right, so I say, okay, I have H2PO4. Now, on the other side of the yield sign, which ion is the pair to H2PO4? They should have the same elements in it. And yeah, you got a phosphorus here, so it makes sense that this one would be the pair, right? HPO4, H2PO4, they only differ by one hydrogen. And then you can kind of check, does the other pair make sense? Well, this one just have oxygen and hydrogen in it, and the other one also just has oxygen and hydrogen in it, water, right? So we picked right. The second thing we're going to do is we're going to get rid of this conjugate business, right? Because we have to find the conjugate acid and the conjugate base. Conjugates are always going to be found on the product side. Conjugates just means basically what the other part of the pair is that's being produced. And you could only produce on the product side. So HPO42 minus would be a conjugate, something. I don't know whether it's the acid or the base yet, but I know it's a conjugate. And the same thing here. Now, that also goes for the actual Bronsted-Lowry acid and base. The actual base and acid that's reacting is on the left side. So H2PO4 minus, I know that that's the Bronsted-Lowry something, so I'll just say Bl. And OH minus is the Bronsted-Lowry something. So now we're going to figure out which one is actually the acid and which one is the base. Pick a pair, any pair. Doesn't matter which one. I guess because I like to work from left to right, I'll go for the greens first. So I'm going to analyze this specific pair. And just know that acids out of the pair always have one more hydrogen. Hydronium, H+, right? So acids have one more hydrogen than their conjugate base. And then vice versa, if you were talking about a base, bases always have one less hydrogen than the acids. But keep in mind that the acids always have one more hydrogen. So just look at those hydrogens between the pairs. In this one, I got H2. I have two hydrogens. In this one, HPO42 minus, I have only one hydrogen. The acid always has one more, so it makes sense that this H2PO4 would be the acid, and it's the Bronsted-Lowry acid because it's on the left side, and then HPO42 minus would have to be the conjugate base. Now you just do the same thing for the other pair. So I'm just going to pick the OH minus and just see what's up with H2O. Acids always have one more hydrogen in the pair. So OH minus has one hydrogen. H2O, H2. It has two hydrogens. So what do you think? This one has to be the acid. It's got one more hydrogen. And then that means that OH minus has to be the base out of the pair. And if you've noticed, on each side, you have one acid and one base. It's always going to happen like that. So if you do this and you see that you have two acids on one side or two bases on one side, go back, try it again. Something went wrong. But that's a good little check for you guys to do during a test or a quiz. But that's it. Hopefully this helped. Thank you for viewing the video. And let me know in the comments what's going on, how you doing in your class. Love to talk to you guys. And I hope you guys are having a great day out there. All right, keep studying hard, and I'll see you in the next lesson. Bye-bye.